Hello and welcome to the lovely Mid Wales Hills on this, the longest day of the year, where we are going to be demonstrating some autonomous off-road driving with our rather large robot, which you'll see later on. My name is Jim Finnis. I work for Aberystwyth University's Computer Science Department.
And I'm Ben Roberts. I'm a postdoctoral research associate at the Pushpire and Upland Research Centre, which is where this demo is taking place today.
So we have some other members of the team who you can't see at the moment, but you may see drift about on camera. Fred will be managing the robot, wrangling the robot, if you like. My colleague Pete is looking after the cameras, and Tom is managing the editing of the video stream. So there's quite a few of us up here, and a rather big robot, Trevan, which you'll be seeing quite soon.
Yeah, so in terms of why does this matter, what are we here to showcase? So really what we're here to do is showcase the potential of autonomous robotics in upland environments. And there's a new facility set up here at Pushpire called the Aberystwyth Natural Terrain for Unconstrained Robotics, or ANTID as its abbreviation goes by, which is also happens to be the Welsh word for adventure. And so one of the things we're keen to demonstrate is one of our robots, Trevan, and its ability to conduct a multitude of different tasks. It'll be performing a couple of tasks for you today, but it's really just to showcase the kind of flexibility of the system and what it can do. And why this is important is there are many things where robotics can offer assistance within these kind of upland areas. And that might be in the case of animal detection and weed detection in order to provide treatments. And that could be taking water to an animal or to see what condition it might be in. Or if it was on a crop setting, it could be to spot weeds and then to deploy some kind of treatment to get rid of those. And a large part of this isn't about taking away jobs from a farmer, it's about assisting them in what they do. So it also might be in locations which are hard to get to. So it could be very steep banks that you wouldn't usually want to drive a tractor on. And yeah, so I'm going to hand over to Jim to run through the demo and take you through what we're about to do.
So what we're going to do is drive the robot towards where we are now. It's currently a long way in front of us. I'm looking at the back of a van with a camera in it, and Trevan is over a hill just in front of that van. The robot is going to follow a road towards us. This is an automatic road following task, not like the kind of road following you have with a Tesla. This is in a lot of ways a little bit harder because this is an ill-defined road across a Welsh hillside. In fact, you can see exactly the kind of road it is. It looks just like that. So it's going to follow this road for some distance, then it's going to turn off the road and look for and move towards a sheep. Now, traditional robotics would have us define waypoints with GPS to do these tasks and move between those waypoints. Instead, we give the robot a plan which is in a language that looks quite a lot like English, that says effectively, follow this road for a certain number of meters, turn off the road at a 45-degree angle and drive for a certain number of meters again, I think it's 50, then turn another angle, drive again, and then look for a sheep, drive towards it and stop. That's the plan. But this is research software and this is a research robot. This isn't a product. It's not finished work. So it could go wrong. If it goes wrong, we'll just start the demo again. Another problem is that we're up here in the hills, a long way from anything. I just glanced over there at the mast that's connecting us to the rest of the world by a series of masts across these hills. Sometimes the video might get a bit iffy, sometimes, or even the connectivity might drop altogether. At the moment, it's good. So hopefully that'll be good. Another couple of things. There's tall grass in this field. You can see that. It's summer. There's a safety feature on Trevan that we'll talk about later, where it will try to slow down or stop to avoid obstacles. If that happens, well, it might think that the long grass is an obstacle and it might slow down. If that happens, we'll deal with it. Finally, that last phase of the demo, detecting a sheep and moving towards it, The sheep detector is not our software. It's an off-the-shelf piece of software. It's not the most reliable thing in the world, so it may fail to spot the sheep. In which case, if it looks like the robot is just going off on a frolic of its own, we'll just stop it. Okay, I think we may be ready to start the demo now. We're going to talk about how the robot navigates a bit later on when you can actually see the robot, but I think we are about ready to actually begin the demo. Okay, nice to see that we've got quite a few people online already. If you have any questions, please ask and we'll come to them when we can. You should be able to see just the top of Trevan. There we go, and it's coming into view now. It's quite an alarming thing. It's an Argo Cat vehicle, 6-wheel. You'll see it in a lot more detail later on. It's doing autonomous off-road driving, following the track, and if we could switch to the visualization so we can see what it sees, that would be great. That magenta blob on the left-hand side of what Trevan can see is where the robot is in a top-down view, and those yellow dots are the path it's taking. So we can see it's now doing a straight drive to a point where it should be able to change direction again. That bottom line on the screen, which says heading/bearing nav, tells us what Trevan is doing. It's driving on a heading using its bearing navigation module. And there we go. That's what I'm seeing now on the left-hand side is my view of Trevan off to my right. You can actually see the sheep in the view on the right there. And there we go. Now driving straight, and it will very soon stop. There we go. Trevan is actually talking to us with a speech synthesizer as it's going. You probably can't hear it there, but it's telling us exactly what it's doing. It just said finished, finished, finished. So that's the demo done. That is a perfectly good run, but we're going to show you some more about Trevan now. If Fred can drive the robot a little towards us. Now you might think it's a bit alarming to have a robot of this size moving towards me, but I'm perfectly safe. Actually, Fred, how much does Trevan weigh? Do we know? Pardon? 400 kilos. So it's a weighty beast. There we go. Thank you, Fred. In fact, we'll do a little demo later on to show you just how. Oh, there we go. Fred didn't actually stop Trevan. And I knew it was perfectly safe for him to do that because of this here. That pair of discs on the top of Trevan here is a LiDAR, a kind of laser radar thing that tells it how far away things are in a stripe in front of the robot. And if anything gets too close, something very low level kicks in on the robot and will stop it from driving. And it will say, as it did there, danger in a West Midlands accent. So we'll have a quick tour of the robot now. You may as well look at the LiDAR. Pete, so Pete is one person who you won't see because he's holding the cameras. This is the LiDAR here. You can see there's the 2 discs and the laser shines out from in between and gives us distance. There's an emergency stop button on the front because it's always good to have as many of those as you can have. But Trevan's main sensors are a pair of cameras that are mounted on this thing high up so that we get a good view of the surrounding area. First is, and I'm going to use my crutch here as a pointer, this assemblage here, which is 2 cameras set about as far apart as a human's eyes. And this is a 3D camera. In the same way that we do, it gives a view of the world in color, but it also gives depth. So we have a depth image of the world as well as a color image. On top of the apparatus, something you might not immediately recognize as a camera is a 360-degree panoramic camera. In that black cylinder is an ordinary camera pointed straight up at a shaped mirror that gives us a view of all around the entire robot. And the way we use this is so that we can tell how far we've turned without the need for a compass. So if you think about it, as Trevan turns, the view of what it can see with that camera shifts from left to right or rotates. And we can tell by how that changes how far we've turned. So we don't need a compass, because in some parts of the world, in the very extreme north, for example, compasses don't work well. We also don't need GPS, because we are just following roads and we are using that compass to navigate angles and drive along them. So that means that we can give very simple instructions to this, and it will into this robot, and it will work in almost every circumstance, as it did then. We've been asked on the stream, how does the robot detect and deal with obstacles, other hazards like holes, rocks, or fences? Holes, it drives over them. Rocks, it drives over them. Fences, the LiDAR will stop it, usually. If it's a fence like the ones that Trevan is driving towards there, that's got barbed wire across them and metal mesh, I'm not sure if the LiDAR would stop it there. Oh, it would stop it there, Fred is telling me, very confidently. So what we're doing now is driving Trevan up a slope and turning it on that slope. It is able to drive up ridiculously steep slopes. I've seen it drive up pretty much 45 degrees. How do real sheep react to the robot? We did have, when we did a rehearsal for this demo, we had the robot actually among some sheep. It wasn't moving. The sheep were a little skittish. Cows, however, were very curious indeed. What software runs on Trevan? ROS 2 perhaps. At the moment, it's ROS. I believe we're moving everything over to ROS 2 at the moment. That is work in progress. So we are using a lot of, or some standard ROS packages and elements. For those of you who are not roboticists, ROS is the robot operating system, and it's used very widely in both research and industry for building applications for robots. It's the standard robot software, if you like, or a standard robot software. We're also using the library that comes with that 3D camera, the Z, to generate depth images, and a whole load of software we've written ourselves, obviously, to do the actual driving and state management. Tom asks, have you tested it in water? Does it still float? Almost certainly not. There's no way this thing is going to float anymore, because we took the seats out. You can see there's a flat bed in the middle of the robot. That's where the seats used to go. And under that, it is entirely made of batteries. And batteries are very, very heavy. So if you were to drive this into a river, it would sink and then it would die. Okay, I think that's it. Thank you very much for joining us on this lovely midsummer's day in mid Wales.